Great day. Today we would like to present assignment for BEKG 2433 Electrical Systems. Title of this assignment is Geothermal Power Generation. Our lecturer is Dr. Aida Fazliana binti Abdul Qadir. We are from Group 6. Our group members include AMIRUL HAZIQ, ANGELYNE, Angelyne, Anis NABILAH, YONG, DALVEEN, Ding Yingshan, Hu Shuhui, and KAVISHA.
Good day everyone, my name is YONG. I would like to present about the introduction of geothermal power generation. The figures show the process of geothermal power generation. What is geothermal? As the name suggests, geo is earth and therm is heat. Geothermal energy is thermal energy generated and stored in the earth which can supply baseload or dispatchable power which is independent of climate and weather. For geothermal power plants, use superheated water to generate electricity and require high temperature, about 300 to 700 Fahrenheit, hydrothermal resource that come from either dry steam well or from hot water well. There are three main types of geothermal power plants, including dry steam plants, flash steam plants, and binary cycle plants. That's all from me. Thank you.
Good day everyone, my name is DALVEEN and today I will talk about the introduction for part 2, which is geothermal gradient. So what is geothermal gradient? The Earth's crust has immense heat, which is thermal energy stored over millions of years. There exists a huge temperature difference between the Earth's crust and the surface. This temperature difference is known as geothermal gradient. This geothermal energy is sufficient to melt a rock. The molten rock, called magma, at times erupt through cracks on Earth's surfaces. These are the phenomena of volcanoes. Geothermal energy is converted to produce electricity. The presence of geothermal deposits in form of hot geothermal fluid is a sign of a good site. The inherent geothermal product should be about 300 degrees Fahrenheit. That's all from me. Thank you.
Basic construction. There are 2 points in this part which are geothermal power plant and geothermal heat pump. The figure shows the basic construction of geothermal power plant. Main items in this figure are hot water, steam, turbine, generator, cooling tower, and injection well. First, hot water is pumped from deep underground. When the water reaches the surface, the pressure is dropped. Then the steam spins a turbine. The steam cools off in a cooling tower and condenses back to water. Lastly, the cool water is pumped back into the earth to begin the process again.
My name is Hu Shuhui. I'm going to talk about the second part of basic construction. Not all geothermal energy comes from power plants. Geothermal heat pumps can do all sorts of things, from heating and cooling homes to warming swimming pools. From the picture below, we can see that water or a refrigerant moves through a loop of pipes. Then, when the weather is cold, the water or refrigerant heats up as it travels through the part of the loop that's buried underground. After that, once it gets back above ground, the warm water or refrigerant transfer heat into the building. Then number 4, the water or refrigerant cools down after its heat is transferred. It is pumped back underground where it heats up once more, starting the process again. And then last one, on a hot day, the system can run in reverse. The water or refrigerant cools the building and then is pumped underground where extra heat is transferred to the ground around the pipes.
Operation or basic principle. The main components of a geothermal power plant are steam turbines, generators, condensers, cooling towers, degassing system, and hydrogen sulfide embalmment systems. A production well is drilled into a known geothermal reservoir. Typically, an injection well is also drilled to return used geothermal fluids to the geothermal reservoir. Hot geothermal fluids flow through pipes to a power plant for use in generating electricity.
Hot pressurized geothermal fluid or a secondary working fluid is allowed to expand rapidly and provide rotational or mechanical energy to turn the turbine blades on a shaft. The turbine drives the electric generator. Rotational energy from the turning turbine shaft is used directly to spin magnets inside a large coil and create electrical current. The turbine and generator are the primary pieces of equipment used to convert geothermal energy to electrical energy. Transmission. Power lines deliver electricity. Electrical current from the generator is sent to a step-up transformer outside the power plant. Voltage is increased in the transformer, and electrical current is transmitted over power lines to homes, buildings, and businesses.
A very good day to our teacher. I'm Anije with the module number of B0520202020. Today I want to present about the geothermal power generator. The part I present is the picture. Okay, let's go to the picture part. Okay, figure 1 is the dry steam power plant. Dry steam power plant draw from underground resource of steam. The steam is piped directly from underground wells to the power plant. The steam is piped directly from underground wells to power plant where it is directed into a turbine or generator unit. From Google, I found that Malaysia have 9 power plants, which 5 in Peninsular Malaysia and other 4 in East Malaysia. Dry steam power plant used is fire station. Figure 2 shows that binary cycle power plant. Binary cycle power plant operate on water at low temperature of about 107 and until 182 Celsius. Binary cycle plants use the heat from the hot water to boil a working fluid, usually an organic compound with a low boiling point. There are 2 types of geothermal resources that can be generated: electricity or EGS, enhanced geothermal system. Another is long temperature or coal produced resource. Okay, let's continue the picture. Figure 3 is the fresh steam power plants. Fresh steam power plants are the common use and use geothermal reservoir of water with temperature greater than 188 Celsius. In the early 20th century, fresh steam power plants were the common geothermal plants on Earth. The water turned to steam. The steam drove turbines. These power plants were used in 24 countries in the world. And figure 4 is the binary cycle plant. Okay, that's all for my presentation today. Thank you very much.
Assalamualaikum. My name is AMIRUL HAZIQ bin SHAHRUL RIZA with matrix number of B0520200039. Okay, for the next part, I will present to you about example of geothermal power generation site. For the first example of geothermal power generation site is Malaysia's first geothermal power plant at Apaskiri, Tawau, Sabah. Tawau Green Energy has received all requisite approval to develop, construct, operate and maintain a geothermal power plant, exporting 30 MW to the Sabah grid. TGE has since undertaken extensive subsurface studies including geology, geophysics, geochemistry and light detection and ranking surveys. For the next example is the gaseous geothermal complex at California, USA. It is located 121 km north of San Francisco, California. It's comprised of 15 power plants, making it the biggest geothermal installation in the world. The complex has installed capacity of 1,205 MW. That's all from me. Thank you.
Good day everyone, I'm KAVISHA THIAGARAJAH. Today, I'm going to present about advantages and disadvantages of geothermal power generation. There are many advantages of geothermal power generation and also some disadvantages that need to be overcome in order to fully exploit the natural resource. So now, let's discuss about the advantages first. It is a renewable energy. It's a source of energy that will last until the Earth is destroyed by the Sun in around 5 billion years. Next, no harmful gases is emitted. Only carbon dioxide mostly will be emitted, which is not harmful but one kind of greenhouse gas. The third advantage is cost of fuel is negligible. Since geothermal energy is a naturally occurring resource, there's no fuel required, such as with fossil fuels that are finite resource, which needs mining and or otherwise extracting from the earth. Then, capital cost is 40 to 60% less than thermal and nuclear plants. Geothermal energy is always available and we don't have to buy it. Next is the construction period is short. The last advantage is corrosive effect of stream tackled by advanced metallurgy. Okay, now let's talk about the disadvantages. The first disadvantage is the availability at certain region only. One of regions that have geothermal energy is magma, which is nearer to the surface. Next, the disadvantage is low efficiency. The conservation efficiency of geothermal power development is generally lower than all conventional thermal power plants. That's all from me. Thank you so much.
Last is our references. Here is our references of our research. Thank you for watching.